Hey guys, how's it going? Hope you're having a good day today. We're going to go ahead and take a look at the last part of section 4.5, which basically ends our chapter 4 unit. Excuse me. So, why don't we go ahead and continue talking about 4.5, which is basically today's lesson. So, it's just a continuation of 4.5, which is on graphing linear inequalities onto the coordinate plane. So let's go ahead and recall something from the previous section. All right, so when graphing inequalities on the coordinate plane, solid lines are used for what signs? Well, we know they're used for the less than or equal to and the greater than or equal to. So solid lines, if they have that little equal to sign underneath, then we know they have to be solid lines. Meaning that for dashed lines, we use the less than symbol and the greater than symbol. Okay, so again, this is just review for what we did on the last lesson. Excuse me. And again, I apologize. I'm still a little sick, so I might sound pretty horrible. So let's go ahead and take a look at what we use when we have a less than. Okay, so when it says less than symbols, so when we have either of these two, we need to identify which way we need to shade. And in this case, for less than symbols, we need to shade below. Okay, so when you think of less than, think of below. And so over here for greater than, which are these two symbols, we're going to use shade above. Okay, good. All right, so let's go ahead and take a look at a few problems to see if we can freshen up our memory. Like I said, today's just an extension of the previous lesson, so nothing brand new here. We're just going to go ahead and make sure we understand and refine our skills by looking at a few problems. So right away here on problem number 1, I'm going to go ahead and try to identify my slope and y-intercept because those two things usually help me graph, but now I actually have my graph and I want to find what the slope and y-intercept are. So here I'm going to identify my y-intercept on the graph, which is actually 0, comma 4. And my slope, well, let's check out my slope. You could just pick any other point here. And I see that there's another point right here. So all I did to get to that point is go up 1 and to the right 1. So up 1 over 1 is just the same thing as a slope of 1. Okay, so we have our slope, we have our y-intercept. Now we have a solid line here, meaning we have to use a less than or equal to or a greater than or equal to sign, right? So those are our two choices because we do have a solid line. Now, in the graph, it looks like we're shading below. So which one of these are we going to use? The less than or equal to or the greater than or equal to? Well, we're shading below, and we said above that for shading below, we have to use less than, okay? So that's the symbol we're going to use. This one's out, okay? So let's go ahead and write our inequality. So we're going to have y is less than or equal to, again, our slope is 1, so I'm going to write 1x plus my y-intercept, which is 4. Now, once you have your inequality written, guys, again, if you want to make sure you did it right or if you just kind of want to get a hint of whether or not you're headed in the right direction, just go ahead and try to either maybe here on the side try to graph that new inequality that you just found, okay, and see if it matches the one that you have above here, okay, or just kind of use it to help guide you and see if your original matches your new equation, or sorry, your new inequality. So again, y-intercept of 4 right here, slope of 1, so 1 over 1, 1 over 1, or down 1, whoops, sorry, down 1 left 1, down 1 left 1, down 1 left 1, down 1 left 1. So it seems to be matching perfect. So that is the correct line. I have a equal to, so it definitely has to be solid, which it is, okay? And also, it's a less than symbol, which means I'm shading below. So all of this right here. So yeah, I just wanted to verify that I did have the correct inequality, and it still meets all the criteria that I asked earlier. Okay, so we have all of our information. So this was, in fact, my answer. Okay, this is the correct inequality. Again, that was more work than we needed to do. Honestly, I just like to always check my work, make sure it's correct. Okay? All right, so let's go ahead and take a look at number 2, and then I'll let you guys try out a few on your own. So let's see what information we have here. Well, right away I see that it's a dashed line, and I know I can identify my slope and y-intercept because right away I see my y-intercept. It's right there. It's at 0, comma, -2. And like I said, to find your slope, just pick another point that you see that hits directly on one of our grid points here in our coordinate plane. I noticed this one is directly on this intersection. Okay, so that's the point I'm going to choose to find my slope. Okay. All right. So then I like to go from my point furthest to the left to the point further to the right. So from here, I'm going to go up 1, 2, 3. So up 3 and to the right 1, 2, 3, 4, 5. So this is up 3, right 5. So my answer is 3/5. Okay, so again, guys, how did I know to choose that point? I didn't have to choose that point. I could have chosen another point. Here's another point that's directly on this intersection on my coordinate plane, right? So that's a good candidate right there. I don't want to use, like, for example, here, this point, because look, the line doesn't even look like it goes right through it. Okay, I don't want to use this point either because the line doesn't go through it. Same thing here. Line doesn't go through it. However, here, in this point on the top, you can definitely use it. Okay, so your slope is 3/5. Now, okay, because it's dashed, we have two options. We have the less than symbol or the greater than symbol. Which one are we going to use? Well, we are shading below, right? We're shading below. Which one of those is going to help us shade below? Well, that would be the less than symbol. So this greater than symbol's out. So let's throw it all together into our new inequality. So we have y is less than my slope, which is 3/5, x minus 2. So my final answer is y is less than 3/5 x minus 2. Okay? All right. So I don't think that was very hard, especially since we got a little bit of practice yesterday. But now I want you guys to get a little bit of practice. So why don't you go ahead and pause the video right now and try out number 3 and number 4 for me, please. All right, let's go ahead and take a look at these two problems. So again, first thing I always check for, guys. Whoops. Well, that's totally fine. Let me change this to my pen, not my marker. There we go. I always find my y-intercept first, guys. So if you guys want to make yourself a little note there, always find your y-intercept first. So I found it right here. That's at 0, comma, -2. Okay, my slope, again, pick a point that is directly on an intersection on those grid lines, okay? I can see one right here. That looks like it's directly on there, right? So again, from my point furthest to the left to the point furthest to the right, looks like I'm going to have to go down 1, so -1, and to the right 2. So my slope here is -1/2. Okay, I have a dashed line here, so I only have two choices for my inequality. It's going to be either less than or greater than. But now, once again, which way are we shading? We're shading everything below. And which one of these two symbols means below? That would be the less than symbol. Okay, so let's go ahead and throw it all together, see if we have our answer. So what do we get? We get y is less than -1/2 x minus 2. And we have our final answer. All right. Good. So I hope you guys are getting those correct. Let's go ahead and check out number 4, see if you guys did well on that one as well. All right. So again, made my little note there to always check for my y-intercept first. Found it. 0, comma, -4. Find my slope. So in order to do that, I need to find a point that hits directly on the grid lines, and it looks like I found one right there. Now, I could have easily chosen this one, because that one also hits there. But honestly, it doesn't matter which one you choose, guys, as long as you get 2 points that are directly on the line that you can tell the exact coordinates for. So I'm just going to go ahead and use this one, since that one's a little closer. So again, from my point on the left to my point on the right, I have to go up 1, 2, 3. Remember, rise over run. So up 3 and right 2. So slope, rise 3, run 2, so 3 halves. We have a solid line in this case. Only two symbols that give me a solid line are the less than or equal to or the greater than or equal to. So which one are we going to choose here? Well, which way are we shading? It looks like we're shading above that red line, okay? Everything above that red line or that red graph that we just graphed, or that was graphed, I should say. So above is what? Is that less than or is that greater than? Well, that is actually greater than. So this less than symbol is out, okay? Let's write our inequality and throw it all together. So we have y is greater than or equal to 3 halves x minus 4. All right. Awesome. So we have our inequality for problem number 4. All right, good. So I really hope this is starting to make a little bit of sense, guys. Like I said, today is really just some practice, and I think you guys will be doing pretty great on the rest of this and on your tests because that should be coming up. Should be the next thing up on the list. So what we're gonna do now is do the reverse. So we're gonna be given an inequality, but we have to actually uh, rewrite it in a way that we can identify our slope and y-intercept in order to actually graph it on the coordinate plane. So let's go ahead and do that first. So we're going to graph the linear inequality, then determine if the given point is a solution to the inequality. All right, so let's test this out. Well, notice in the above, and actually let me scroll up so you guys can see it. Notice on the above problems, all of my inequalities that I just wrote, this one, this one, this one, and this one, they all have the y all by itself. Why is that? Well, the reason why is because I want to have it in slope-intercept form. Okay, so what I want to do is get this new equation here, sorry, this new inequality here in slope-intercept form. So in order to do that, I have to isolate the y. Okay, well, what's in the way of the y? This x is in the way, so let me get it out of the way first. Okay, so what do we get? We get 2y is less than negative x minus 10. Now I want to get rid of that 2. So I'm going to divide everything by 2. So I'm going to get y is less than negative 1/2 x minus 5. And again, no reason to move the symbol or flip it because we divided by a positive. So this is my inequality. All I need to do now is write down what my slope is. Well, my slope is negative 1/2. My y-intercept is 0, comma, negative 5. Remember, make sure you're writing this right here as an ordered pair. It is a point, okay? So it has to be as 0, comma, negative 5, not just negative 5. Okay? Now, we have a less than symbol, not a less than or equal to. Okay, no equal to here, so we're going to have a dashed line. All right, so let's go ahead and actually start graphing this thing. So I'm going to start at my y-intercept. My slope is down 1, right 2. Okay, so down 1, right 2, down 1, right 2, down 1, right 2, and I could keep going. Or I could do the exact opposite, which is up 1 and left 2, up 1, left 2. Okay, I'm not going to make that many more points there. All I have to do is now connect them all with a dash line. Okay, don't forget your arrows at the end. So I have my dash line. Last thing I need to figure out is, am I going to shade above or below? Well, this is y is less than, so when I think of less than, I know I have to shade below that red line, which would be all of that right there. Okay, so I have my inequality graphed. I have a dashed line, and I shaded below. Now I want to check that test point. Well, which was my test point? My test point is -3, -3. Now, we want to know if that's a solution, yes or no. I like to always make the prediction first. Or not even a prediction, it's an actual analyzation, but where is -3, -3? Well, that would be to the left 3. It'd be right there. Okay? Well, I can tell right now that that's above my dash line. Okay? So it's not going to be a solution. And actually, even if it was on the dash line, like right directly on the dash line, it would still not be a solution because remember, points that are on the dash line are not solutions, okay? If they were in a solid line, then yes, they would be solutions, but because it's a dash line, it would not be a solution. In order to have a solution here, we would need to have like a point somewhere over here in the shaded region, okay? But again, that in a way is almost like a prediction. So I'm going to go ahead and say no, but let's actually test it out. That's the reason why we have this little space here. So what you want to do is take that point. Again, this is your x, this is your y. You want to test that by substituting it back into the original inequality. So let's do it. Scroll up real quick. Okay, so we have x plus 2y is less than -10. That's my original inequality. Okay, so let's go ahead and substitute my values in here. So I have -3 plus 2 times -3 is less than -10. So let's see if this gives us a true statement. This is -3 plus 2 times -3 is actually a -6. So I'm going to change that to a -6. All right, what do we get? We get -9 is less than -10. Is that true? No, that is not true. Okay, it is not true, and so it's not a solution, just like we observed when we were looking at just the graph. Now, you can use your original inequality, but because you figured out a new way of writing that inequality in slope-intercept form, you can also test it out using that. So, but the result should be the same, guys. Again, you could choose whichever one you want, but the result should be the same. Okay, so let's see. What do we get here when I substitute? I get -3 is less than -1/2 times -3 minus 5. This is -3 is less than, this is a positive, I should say. Positive 3/2 or a positive 1.5, whichever one you want to do. I'm can write it either way. So then we have -3 is less than, if you actually calculate this out, this is a -3.5, or again, it would be a -7/2. But I'm only writing it as a decimal to make the point clear here. -3 is less than -3/5. Is that true? No, it's not. Not true. So again, the answer is no. -3 is not a solution. Last thing I want to tell you guys here is try to always use the original inequality for your test point. Okay, so when you're testing out to see if a point actually works, use your original inequality. The reason I say that is because if you use this new one that you just found, the rewritten formula or the rewritten inequality, you might have done an error as you were finding out this new inequality. Okay, if you did make an error, then regardless of whether you tested correctly, it might give you a wrong answer. That's why if you always stick to using the original inequality, then you should always get the correct answer. Okay? All right. Again, I know I extend those types of problems a little bit, guys, but I want to make sure you guys understand and have multiple ways of doing these problems. So we're going to fly through this one a little quicker now. So we have 2x minus y is less than or equal to negative 2. Same thing. In order to find my slope and y-intercept, I need to make sure I isolate the y. So let's get rid of my 2x here. So I get negative y is less than or equal to negative 2x minus 2. I don't want a negative y, I just want a y. So I'm going to divide by negative 1. But again, I divided by a negative, so because I divided by a negative, I have to flip. So I'm going to flip it now to a greater than or equal to 2x plus 2. So my slope here is 2 or 2 over 1, whichever one you want to write. And then here is 0, 2 for my y-intercept. And because I have an equal to, a greater than or equal to, I'm going to have a solid line. So let's start graphing our lines here. Okay. So I'm going to start at 0, 2. My slope is up 2, right 1. So I'm going to go up 2, right 1, up 2, right 1, 2, right 1, or the opposite, which is down 2, left 1, down 2, left. Okay. This time I do have a solid line, so I could just make a line straight through all those points. Now we have to figure out, are we going to shade above or are we going to shade below? Okay, so let's see. We have y is greater than or equal to 2x plus 2. Greater than means above. Okay, you have to ask yourself, which way is above? This side that's almost like on the left side of that line or on the right side? Well, think about it. And this is one way to figure it out, guys. Let me go ahead and use a different color here. If you're not sure if this, so let me use a highlighter here. If you're not sure if this is above or if this is above, you can always do this, guys. And let me show you a quick trick. If you go anywhere on this line, on this purple line, and if you make arrows that are perpendicular, so making 90-degree angles, okay, or in the other direction, let me use green here. See how they're making like little 90-degree angles here, guys? Which one of those, the reds or the greens, look like they're kind of going up? Remember, we're trying to shade above. So which one of those look like they're going up? Well, it looks like the red ones are going up. They're going to the left, but they're also going a little bit up. So the way we have to shade is right over here. Okay, now this was only a little kind of mini lesson for those of you guys who are still struggling with figuring out which way to shade. I know most of you guys already do know how to shade, but if you're still a little confused on that, guys, remember, you can use this little trick to help you figure out what means above. Is that to the left side or to the right side of that line? Okay, so I'm going to erase this just because we don't need it anymore. So now we have our graph. Last thing, he wants to know if negative 1, 1 is a solution. So let's go ahead and see. Well, negative 1, 1 is right about here. Looks like it's right there. Now, that is on the left side of my line. Okay, it's in the shaded region. Okay, it's to the left side of my line. So it should be a solution. Okay, so I'm going to go ahead and make my, like I said, make almost like a prediction here. But I'm going to go ahead and say yes. This negative 1, 1 is going to be a solution, but let's test it out. Okay, again, I'm going to use my original inequality just because I think you'll have less errors if you use the original. Let's put it that way. So I'm going to do 2x minus y is less than or equal to negative 2. I'm using my original inequality. I'm going to substitute in my values here. Again, this is my x, this is my y. So I get 2 parentheses -1 minus 1 is less than or equal to -2. This is -2 minus 1 is less than or equal to -2. So -3 is less than or equal to -2. Is that true? Is this right here a true statement? Is -3 less than or equal to -2? Yes, it is. And because it passed our test, okay, by substituting it back into the inequality, and it also passed our visual test, which is by just looking at it up on the new graph that we have, we know that this is definitely a solution. Okay? All right. I think we are good with that. Now the rest of this is more so a review of the first few sections of chapter 4. So let's go ahead and recap a little bit on how to do those, and we will be finished with today's lesson. So number 7, we have an inequality and it's being shaded to the left. Okay, so I'm going to write down my x and my 3 just like I always do. Now this is going to the left, meaning we have a less than symbol. Again, notice what I traced out right there, guys. See how I trace, whoops, that's not a good color to choose. What I traced out there and the symbol I'm using, notice they're both going to the left. Okay, so that was our little trick. Hopefully you guys still remember it. Okay, now do I need an equal to sign underneath? Yes, I do, because it's a closed circle. So it's it's x is less than or equal to 3. Okay, now the next inequality, we have x and 7. And remember, there's a gap here, so this is an or statement. So I'm going to say or x and 14. Now I just have to figure out what symbols I got to use. Well, again, at the 7, we're shading to the left. So I'm going to do a less than symbol. And it's an open circle, so no need for an equal to sign underneath. On the 14th, on the 14th, not the 14th. On the 14, I'm shading to the right. So I'm making a wrong place. I'm making a greater than symbol, and because it is a closed circle, I need my equal. So let's go ahead and read this out loud as if we were actually using words. We would say that x is less than 7 or x is greater than or equal to 14. Okay, again, anytime you see a gap here, guys, you always have an or. Again, you don't have to write it on the actual number line, but just know that this is an or statement. You're shading to the left or to the right. Okay, now this last one, notice the shaded region is in the middle. Okay, it's all right here. So then all my solutions or all my x's have to be trapped in the middle between these 2 points. So that's exactly what I'm going to do. -1, trap the x in the middle, and then the 5 at the end. Now we just have to figure out what symbols to use. Now, I've told you guys before in the past that for these and statements, remember these are and compound inequalities, okay? We will always be using those less than symbols between the two numbers, okay? Now it's just a matter of figuring out whether they're going to be less than or equal to or just less than symbols, okay? Well, let's see. This is just an open circle. This is just an open circle. So no need for equal to signs underneath any of those. So this right here is our final answer, okay? So go ahead and circle in all your answers here. And hopefully if you did move on ahead and now you are looking at this part of the video, you can verify that you got your answers correctly. Okay? Now, these last few, we have a little reminder here. It says when multiplying and dividing by a negative number, be sure to flip the inequality sign. Okay, so don't forget that, guys. Whenever you multiply or divide, so multiply or divide by a negative number, you have to flip the inequality. All right, so let's go ahead and do problem number 10. Well, my x is trapped in the middle, so I need to get rid of everything else except for the x. So let's get rid of this 20. And remember, because there is multiple inequalities here, because it is a compound and inequality, then you have to make sure you subtract the 20 from all three sides. So we get negative 110 is less than negative 10x is less than or equal to 80. Next step, get rid of that negative 10. So I'm going to divide by negative 10. Now I divided by a negative 10, so let me actually finish this up here. Negative 110 divided by 10 is a positive 11. These go away, so I just have an x, and these turn into negative 8. Now, because I divided by a negative, I have to flip, so now my symbols are going to become greater than and greater than or equal to symbols. All right, so we flipped right here. Now, another thing that you always have to remember, and maybe add it to your reminder, always have your smaller number on the left side for and inequalities. Okay, so always have your smaller number on the left side for the and inequalities. Between the 11 and the negative 8, we can see right away that the negative 8 is the smaller one, so I actually want to rewrite this. Now, again, this one right here is called a rewrite, not a flip. Okay, we're going to rewrite this, so I'm going to put the negative 8 here, the x still in the middle, and my 11 on this side. But now, you have to remember, guys, you are just rewriting. You're not flipping, okay? So you're rewriting the entire thing, not just flipping the symbols. So we have to remember which way these are facing. And like you guys know by now, I like to draw an imaginary Pac-Man here. What is my Pac-Man eating? Well, it's eating the 11. So when I redraw it, I have to redraw it so it's eating, or the mouth is open towards the 11. Same thing here. I have a Pac-Man here. Between the 8 and the, between the x and the negative 8, it's eating the x, so it has to eat the x. Just don't forget your little equal to sign here. All right, so let's see. This is my finished written inequality. So now I can go ahead and actually graph it. And I don't know why my graphs are all the way down here, but let's go ahead and do our negative 8 on the left, positive 11 on the right. Okay, now by the negative 8 right here, excuse me, I have a less than or equal to. So because it's an equal to, I'm going to have a closed circle over here on the side with the x and the 11. I have a less than symbol, so no closed circle. We're just going to have an open circle. All right, and again, remember, guys, where is the x here in my entire inequality? Notice it's right in the middle. So where am I going to shade? I'm going to shade in the middle. It's an and compound inequality, and compound inequalities we always shade in between. Okay, all right, last one. Actually, I want to see how well you guys remember these OR inequalities. So why don't you go ahead and pause the video real quick and try these out. All right, so let's figure these two problems out, and we will be done with our unit. So I want the x all by itself, so here I'm dividing by a negative 6, so how do I get rid of that? I have to multiply both sides by a negative 6. Now these two go away. I'm left with x and a negative 6. But remember, I multiplied right now by a negative number. So I have to flip. So my symbol now is a less than or equal to. Okay. Or let's do this right side here. I have to get rid of my 6. Get rid of my 6. So I get negative x is less than 4. Then we have to divide by negative 1. Again, once again, I'm dividing by a negative, so I'm going to flip. So my answer is going to be x negative 4. But since I flipped, this is now going to be an x is greater than negative 4. So my answer now okay. And even for this, so you can extend this right here, guys. This little note I made for you guys on the side. You can extend it for or inequalities as well. Make sure that the small piece of the inequality that you have here on the left side is always the smaller number, which it is, negative 6, and the larger number on the right. That'll make sure that you always graph your inequality correct. Now, I don't want to scroll down all the way over there to find my graph, so I'm just going to draw a new one for you guys. Smaller number here on the left, larger number on the right. Okay. Right here, I have a less than or equal to, so I'm definitely going to have a closed circle. Less than means left, just like right here. So I'm going to shade to the left. But this is an or compound inequality, so we know we're going to shade to the left or to the right. So let's figure out what we got to shade here to the right. Well, we have an open circle, and it's saying x is greater than, so what are all the values that are greater than negative 4? It would be all the values to the right. Okay, notice again there's a gap between the two shading regions that confirms that we did graph an or compound inequality. So we are done. All right, guys, so hopefully you got this correct and you are pretty confident about your skills from chapter 4. So I would recommend to you guys now that you do some of the unit reviews and the chapter 4 practice tests. That way you guys will be ready and confident for your unit test. All right, guys. Well, I will talk to you a little bit later, and yeah, have a good one.